Today, if you would look at the whiteboard, our lesson plan title is Chemical Reaction. And the topic that we're going to teach is reactions and equipment. Now, the objective for today, we are going to explain why a chemical reaction has occurred. Now, of course, you know I have to be outside on hall duty, and you've already done your bell ringer. And the bell ringer was, we are to write a paragraph explaining what do the foods you eat, the fibers in your clothes, and the plastic in your water bottle, what do they all have in common? Just think about what I've said just for a moment, okay? And then kind of brainstorm and talk to each other and tell me what you think. Okay, the clothes, you know, plastic water bottle, what do you think they have in common? Anybody?
They're all made.
They are all made, great. Anything else?
They all wear.
They all wear, okay. Plastic water bottle, the clothes that you have on. What do you think they have in common? That's great, great answer. Anybody else?
They come from the earth.
They come from the earth. All right, and how do
Use them
they
every day.
use it every day? And how do they look? The plastic water bottle, the food we eat, the clothes that you have on, how do they look?
Look good.
They look good, okay? Are they the same or are they
They
different?
don't look the same.
They don't look the same. Well, that's what a chemical reaction is.
Okay.
It's rearranging things so that they don't look the same. So if you want to go back to it, you can. See, if you burn a piece of paper, it's going to what? Change form, isn't it? And usually the color that you get is what color? When you burn something, black. So if it was yellow originally, can you go back to that yellow color? Because you have rearranged the appearance, the texture. If you would look, if you will, real world application. How many of you have ever bought bananas? Well, when you go in the store, and if they have just placed the bananas, out, what color do you see?
Green.
Green, and then eventually it goes to,
Yellow.
and then it eventually goes
Black.
to, oh my goodness, what are you telling me?
It's a chemical reaction.
Oh man, you are just awesome. How do you know it's a chemical reaction?
Well, by the changes that take place.
Okay, what
Phys-
kind of changes?
Physical change. They
Physical?
can be seen.
But a physical change, you can go back to it. But a chemical change, you can't go back. It's irreversible. So both, could be correct. But a physical change, you can go back and reclaim it. Say an example, if I mix sand and water, I can go back and get that sand, can't I?
Yes, you can.
But if I mix vinegar and baking soda, it's gonna bubble and bubble. Can I go back and get that? No. So that's how we can tell the difference between a physical change and a chemical change. Now this banana, you said it went from green, it went to yellow, then it went to black. Can I go back and get those colors?
No, you can't.
So what kind of change is that?
Chemical.
So that means that color is one way to recognize a chemical reaction or change. Okay, now very good. Now if you would look at your vocabulary, all right, a chemical change and a chemical reaction, just take a moment if you will, and look at your textbook for me. That's your textbook that you have. And I want you to tell me, let's look at your vocabulary list. 2 words up there have the same meaning. What are those 2 words?
Chemical reaction, chemical change.
So that's okay. So if you say, oh, chemical change, oh no, I meant chemical reaction. No, they mean the same thing. All right, so that's okay. So if you would look, our objective, we want to explain why a chemical reaction has taken place. So if you would look in your text, I provided for you some means to identify chemical reactions. So when we do our demonstration, we'll be able to identify the reaction type. So you've already told me one evidence of a chemical reaction, that was color. And you did that on your own. So what are some other ways we can tell, going back to our objective, explain why a chemical reaction has occurred? We can look at the color and tell that a chemical reaction has taken place. What are some other things? Smell, texture, smell, what else?
The formation, like a solid or liquid.
Very good, very good. Like, say for an example, if I take this plastic bottle, and if I melt this plastic bottle, what is it gonna do?
Change.
It's gonna be a chemical thing, but you can't get it back.
There you go. Right, very good, you can get it back. So those are things that will let you know if a chemical reaction has taken place. Now, how many of you have ever taken an Alka-Seltzer? You put it in the water and what happens? Fizzes up. What if, how many of you have ever washed dishes and you put your dish detergent in and you said, well, I need to sterilize something. And then you take the bleach and mix it with the detergent. How many of you have ever done that? Oh, okay. So what's gonna happen? Just now, when you mix the bleach and the detergent, what do you think you're gonna get? Yeah, because you're gonna get some kind of smell, aren't you? Okay, very good. Now, what I'm going to do, I want you to, you're already in your groups, and I want you to brainstorm, pull your ideas together, and come up with an everyday common occurrence that we've not talked about that's a chemical reaction. And then tell me what you use to identify it as a chemical reaction. I want the class, to brainstorm. And remember, a chemical reaction, you're rearranging some things. And it has to be evidence in order for you to identify it. Okay, so would you kind of like get your chairs together and come up with everyday common occurrences, things that you might encounter in your home or things of that nature. We'll give you a couple of minutes, and then we'll come back.
One common occurrence.
What about your well, it'd be a physical change. Curling your hair going from when you wash your hair and then you straighten your hair. But that's a physical, because you can go back and get that.
Very good. Fantastic. I like
What if
that.
we mix two different types of dyes together, colors, like it's Easter season, and if we mix a yellow and a blue, we're gonna get what? Green.
Very good. That is awesome. Fantastic. Because you cannot go back. Exactly.
Right.
And then there are some things, I don't know whether they still do it to speed up the reaction. And it's, well, what do they usually do to speed up the dyeing process? Or do they just, they don't do that anymore?
Put vinegar in it.
Oh, that is just great. And the vinegar, and it's kind of like a catalyst. A catalyst, it will speed up or slow down the reaction, but it does not interfere with it. That is fantastic, fantastic.
Most mornings I do oatmeal.
Okay.
I take those rolling oats, and when you heat them up with that water, you're not gonna be able to go back and get them in that form.
That's a good example.
Fantastic. All of you have just provided excellent examples. Excellent. Now, let's go back. All right, a chemical reaction. That's the overall general topic. And then the subtopics, reactions and equations. So taking our objective from our subtopic, what we wanted to do, we wanted to explain, and you've done that. We wanted you to explain how you could identify that a chemical reaction has taken place. Then we looked at our vocabulary list, and you did such an awesome job. Chemical reaction and chemical change. What can you tell me about that?
They're the same.
Oh, fantastic. Evidence of a chemical reaction. What are some evidence of a chemical reaction?
The odor, the change that it can't go back. So you exit down and you can't go back.
Okay. Now, what I want you to do, I want you to select one of these brilliant students here, okay? And I want you to ask them, can you identify anything about this gorgeous shirt that he has on? Can you identify any type of chemical reaction as far as the process as to how it was made or stitched together or anything of that nature? Can you get me a chemical reaction from that shirt that he has on? Can you explain?
I know it didn't start out as those, small, checkered plaids. So something was done to get it into that form.
Very good. And where do you think the materials came to get this shirt in this form?
Okay, that looks like a cotton shirt, so.
Very
it came
good.
from
It
Raw
came from
material.
raw. Oh, this is fantastic. So you see all of the chemical reactions we have around us. Now, before we end our lesson for today, all right, are there questions? Okay, you've done such an awesome job. What I'm going to do now is I want you to write in your journal. I want you to write in your journal. You don't have to do this. I want you to write in your journal. I want you to give me a paragraph, all right, describing how you can identify a chemical reaction. Then I want you to give that journal, all right, you're going to exchange journals. And then I want them to add a chemical reaction to your journal. And then when you get through, you'll pass it in to me, and you'll get 30 points for each entry, all right, for your effort. As long as you write something, if you're not sure, I want you to cooperatively get together, say, I'm not sure about this answer. What do you think I need to put here? Okay? So,
So if I add something, do I need to add my name?
yes, I want you to write your names on your paper, and then you'll pass your papers up to me. If there are no questions, are there questions? So this concludes our teaching process. Good job.